Hello friend, we will be we are now in the third part of your infrared spectroscopy that is related to the instrumentation and some application part. The learning outcome. The learner will be able to explain the instrumentation and components of IR spectrophotometer, discuss the different sampling technique used in IR, describe the various application of IR spectroscopy. Now, what are the various types of instruments used? So we may have heard about the two type of instruments. One are called as a process instruments. They are the filter-based instruments, and another are the laboratory instruments. We are generally dealing with the laboratory instruments, which are of two type again, dispersive, which uses the monochromators, and the another one is your Fourier transform instrument, which uses an interferometer. The newer instruments, they uses the interferometer systems only, Fourier transform. But we had to learn this dispersive instrument also. So the instrumentations, all of you know the various components of instruments. The first one is your sample holder. See, there is small change. First one is your sample holder. Second one is your sample holder. First one is your source. Second one is your sample holder. Third one is your monochromator. Fourth is detector and readout unit. This is the small change in the previous things what we have learned in UV visible, that is source, monochromators, then sample holder. Here source, sample holder and monochromator. Various sources which we are going to learn are nurse glower, then glow bar source, in incandescent sources, wire sources, and then mercurial clamps, then sample holders we'll see separately. Then monochromators are gratings and filters. Then detectors, they are generally the thermal detectors having the thermocouples, thermopiles, thermistors, bolometers, and pyroelectric detectors. And the simple one is your readout devices, they are recorders. Now we'll see the first component, that is the source. Continuous sources are generally utilized. We know that there are two sources. One is line sources, another one is your continuous sources. So tungsten incandescent lamps are generally utilized. They are the similar to a black body emitters. They are source of the measurements in the near infrared regions. So they are utilizing the nichrome wires. Okay, so they are using the nichromes or ruthenium wires coiled in a evacuated chambers, which is heated by the resistance to incandescence. So there are black oxide layers forms on the surfaces which emit the radiations in the IR regions. They are working at a temperature of 1100 degrees centigrade. They require little maintenance and no cooling is required. They emit the mere infrared radiation, but less powerful than the other sources. But they are also used in the cheaper instruments. These were used in the old instruments. The another source is your nursed glower. So nursed glowers are constructed of the rare earth oxide. They are the more intense emitted radiations than the previous one. So it is a cylindrical rod or a tube composed of a mixture of certain oxides such as the zirconium oxides or deuterium oxides and EBM oxides at a ratio of 90 as to 7 as to 3 by weight. The platinum leads are there on both ends of the cylinder, permitting the passes of electrical current. They are non-conducting at ambient temperature, but at a temperature more than 800 degrees centigrade, it is electrically conducting, maintaining the high temperature by resistive heatings. They are good energy. They are having the good energy output. Its output is double that of the nichrome wires or glow bar source. They are used in the absorption instruments. The another source used is the glow bar source. It is a silicon carbide rod of 5 to 10 width. So these are the silicon carbide rods of 5 to 10 width and 20 to 25 length, which is electrically heated up to 1000 to 1650 degrees centigrade. Their characteristic their characteristic is line is between the nichrome wires and nurse glower. They are self-starting and operates at 1300 degrees centigrade. The glow bath must be water-cooled by the brass jacket which is surrounded onto them. Otherwise, the heating will produce the stray radiations. So carbon dioxide lasers are used in the today's FTIR instruments. So they are useful in the narrow bands and they are the modified form of the sources which are there in the FTIR instruments. Now we'll see the second component, that is a sample sale and the sample preparation. So the sample sale or sample holder used for different types of the physical state, that is either solid, liquid and gases. Material containing sample holder must be transparent to the IR radiation. So we cannot use the glass cuvettes or quartz cuvette because glass and quartz are not transparent to the IR radiations. So sample cell generally constructed from the rock salts such as your potassium bromide, selenium bromide or selenium iodide. Sample must be pure and free from the water, that is the minimum requirement for IR spectroscopy. So different sample cells are used for the different physical states. There are the different sample cells for solid sampling, then liquid sampling and gases sampling. This sample cell is to be incorporated with this disc into the instruments. So we'll discuss this in detail. Now we'll first see the sampling of solid. Solid generally dissolved into the particular solvent and used as a solution. So this dissolved solid sample in non-aqueous solvents. We cannot use water as one of the solvent for dissolving the substances. So because it is IR inactive solvent should be used and place a drop of this solution in alkali metal disc which is then mounted onto a spectrophotometer. Examples of solvents which are used includes acetone, cyclohexane, chloroform, carbon tetrachloride, etc. The another method is forming the solid film of the substance which is to be determined in IR spectrophotometer. Here the amorphous solid is dissolved in volatile solvent and this solution is poured onto the rock salt plates. Okay, that they are either the KBr plates or the sodium chloride plates. Then the solvent is allowed to evaporate by gentle heating and leading to the formation of a solid film which is then held into the instruments. The another technique for handling the solid is a Mull technique and another one is your pressure plate technique or KBR disc technique. So now we'll see the Mull technique. Mull technique, that is a formation of a mull. Mull means it is a paste of sample material with mineral oils. So mull is formed by grinding the sample with 2 to 5 milligrams of sample is taken and 2 to 3 drops of nuzol, means that is hydrocarbon oil, is added into that material and it is saturated in a small mortar and pestle to so that it can form a paste. The resulting mull is examined as a film between the two salt plates which is sandwiched between the sodium chloride or potassium bromide plates. So finely powdered samples plus mulling agents, that is nuzol, is used, making a thin paste which is called as a mull. That is transfer mull to a mull plate and the plates are squeezed together to adjust the thickness and then it is mounted in a spectrophotometer. So such type of the small mortar and pestles are used where the sample is added and it is mixed with the nuzol and it is applied onto KBR disc which is sandwiched and which is then used. I will show the video of this in later part. Now we are having the KBR disc method, or that is called as a pressure plate techniques, in which the finely powdered sample is mixed with about 100 times its weights of the KBR. Dried KBR is used in a vibrating ball mill, or we can have a small mortar and pestles like we have seen in the previous slides. So, and the mixture is then pressed under a very high pressure in a evacuable die to form a small pellets. The pellets is of 1 to 2 mm thickness and 1 centimeter in diameter. So you remember this diameter of the pellets which are used in the IR. So they are generally asked in the MCQs. So advantages: eliminates bands which appears due to the mulling agents. because Nuzol itself has certain absorption abilities, so it may produce the absorption, so that can be avoided. So the pellets can be stored and they can be used, reused whenever required, so they can be used as a reference material. So their longer period of time they can be stored. Their concentration of the samples can be adjusted within this um, mm, pellets and they can be used. But it has certain disadvantages that it is not suitable for polymer which are difficult to bind with the KBR. And the pressure which is we are using to compress this material may change the crystalline nature of the sample, that is now known as a polymorphism. Means due to the higher pressure, the crystal forms will change to certain polymorphic form which is not desired. So for your better understanding, I will show you, this is the dies and punches which are used for forming the pallets, and this is the die pressure machine which will produce this tablets. So I will show you the video for better understanding of this device.
Samples.
See, for the sample preparations, we are taking some mortar and pestle of particular material. Um, Lead or some graphite materials are used to form these pestles and mortars of specialized material. They are thoroughly clean before they are to be used in the instruments. So these are the another evacuable pallet press, upper part and lower part, which is used in the instruments for formation of the pallets. There is a bolt press which is used for equal distribution and pressing purpose, and this dies. Then this is a manual hydraulic press where the sample is to be pressed in a form of a thin film. Let us follow the procedures for preparation of the pallets. So the procedure includes first formation of the blank KBR preparations. For this, we need that cleaning of the all components thoroughly is required so that there should not be any previous residue of material adhere to your covet or what is called dies and the holders. So these are all cleaned thoroughly with tissue paper first. Then this is your chloroform, which is used as a solvent. It is a wash bottle not containing water but containing the chloroform. All parts are cleaned thoroughly with chloroform. Then they are wiped out with the tissue papers so that it is completely free from adhered material and very clean for operations. So this is the cleaning of your surfaces. This is done with the tissue paper, and care is taken that there should not be any residue adhere onto the surfaces. So all die part is also cleaned thoroughly. Then it is dried with the tissue paper so that there should not be any chloroform retained on the surface. The mortar pestles which are used are again cleaned thoroughly with the chloroform because previous residue should not be there. It is to be thrown out. Then again it is dried with the tissue paper. Now this is the dried KBR which is taken into the mortar and pestle. It is thoroughly grounded to a fine powder. Then the upper part of your die is fixed with the bottom part. One dice is inserted. The KBR is slowly added into this with using small transferable spatula. Then the bolt is inserted and it is rotated so that the material will get equally distributed in the cavity. Then the another punch dice is added. The bolt is fixed. Then this is to be transferred into the hydraulic press. It is screwed in such a way that the compression will take place in the hydraulic press. You have to be very careful. So rotate till it get pressurized. Pull the lever repeatedly so that it can meet 10 TMS or 10 pounds in our instruments. Wait for 2 minutes so that there is a compression. Proper compressions will achieved, forming a pallet. Then release the knob by rotating it into the anti-clockwise direction and unscrew the dies and punches. That will remove the whole set from hydraulic press. Remove the upper part from the bottom part by rotating slowly. The dies are there on the place and it is inwardly kept into the base, and a adapter is assembled so that by applying certain pressure, the pallets will come out. A care should be taken that pallet should not get broken while you are applying certain pressure. So rotation wheel is allowed slowly on the surface so that the bolt will pull out the pallets. So ensure that the force extra exerts on the middle of the press, it should not cause any breakage of your KBR disc. So then it is removed. See, this is the KBR disc. Okay, this is the first dies removed. Again, the bolt is pressed so that the another dies will come out, showing you the small KBR disc, which is then placed into the holder. We have seen the holder. Okay, screw cap holders are shown here. It is placed into the holder. It is screw capped, and then it is kept in the instruments for recording of the background. Okay, it is to be placed in the instrument like this so that it will record the background for the KBR. Now, sample preparation. For sample preparation, the procedures are again same. Clean every part of the instruments thoroughly with tissue paper first, then with the alcohol, sorry, not alcohol, it is a chloroform. You have to clean it thoroughly. Then you have to wash with the chloroform. Again, the rinse to dry. Okay, so here the dies, punches, and everything is to be cleaned thoroughly before it is to be used for the further use. Now again the motor pestle is again taken. It is again cleaned thoroughly. Now for preparation of your sample, this dried motor pestle will use. Okay, the sample is to be, a small quantity of sample is to be placed into the motor and pestle. Too much sample should not be used. Okay, so dried KBR is added. It is saturated in such a way that it will get thoroughly mixed, grind well using the pestle. For the sufficient period of time. Then again press the dies, place a small sample into the cuvette, place the another dies, rotate the bolt so that there is equal distribution in the hole, press the second dies, press the bolt, transfer whole assembly into your hydraulic pressure, apply the pressure 10 TMS, wait for 2 minutes and release the pressure, turn the wheel to remove the dies and punches. Again invert this dies device, place the adapter for removing. Again keep into the hydraulic press, apply the pressure and remove the sample disc slowly. Place the sample disc into the sample compartment, screw it, fix the cap and place into the instrument. In this way, hydraulic dies and punches are used to prepare the pallets for the IR spectroscopy. Then sampling of liquid. Generally, the liquids are sampled into the sample cells. So sample cells again, we cannot use glass or quartz for the construction of sample cell. They are using the two windows of pressurized salt which is sealed. Samples that are liquid at room temperature are analyzed in pure form or in the solution form. 1 to 5% solution is placed in the solution cell made up of a metal halides, and a second cell containing the pure solvent act as a reference. So two cells we need to keep into the instruments, double beam instrument. Impart the solvent use. Generally we are having the chloroform, carbon tetrachloride, carbon disulfide as a common solvent. The solubility is a major disadvantage for such solvents, because many substances are not soluble in such type of the organic solvents. Again, we cannot use other solvent because themselves they shows you certain absorption. So liquid samples can be sandwiched between the two alkali halide plates, which are of the KBr or in sodium chloride or calcium fluoride. This is again the important point, that the thickness of the sample cell is generally 0.01 to 0.05 mm. Okay, so see here in the picture, you can see the two KBr disc or two uh, selenium bromide disc. Okay, the sample is to be dropped in this. This is the gasket which will decide how much distance is there between these two plates. So either we can have the fixed path length cells, or we can have the variable path length cells between 0.01 to 0.05 mm. The another disc is to be placed, and then this whole assembly is to be held into the instruments. So I will show you the video for this again. See the video. So in infrared spectroscopy, preparing of sample for infrared spectroscopy, we are the thankful to the video makers for allowing us to use it in our video teaching method, teaching material. So a sample, this is a Mull technique I am explaining first. For the Mull technique, again the sample is to be triturated thoroughly in small mortar and pestles. Then the nusol as a mineral oil is added dropwise. Few drops of this mineral oils are added to the sample, and it is again mixed and thoroughly triturated to form the paste of the materials. We have to be very careful that we should not use the excess quantity of the nusol while forming this paste. It is to be placed between the two KBr discs, which are placed into the desiccators. This is a small desiccators having the desiccants at the bottom. It is kept slowly in the cottons. So when we are handling these plates, our hand should be dried. There should not be any moisture, and there should not be any aberration produced onto the surfaces. So the material is applied with the small spatula. Care is to be taken that when we are applying the material, the spatula should not produce any scratches on the surface. Otherwise, this disc will get destroyed. Sufficient quantity of sample is applied. Now another disc is placed, and it is pressed in such a way that a smear will be formed, a paste will be formed between these two KBr discs. Then this KBr disc is to be mounted into the holder. Two types of holders are used. I am showing both of them. So this is the gasket which is holding. Then the another plate is to be placed on the surface. Rubber gaskets are there for the protection purpose. When we are applying the pressure, the equal pressure should be applied on all board so that there should not be any crack in the plates. Okay, so equally we will tie this plate, this screw. Then this is to be see like this is the smear which can be placed into the compartment. The another holder is available that is known as a spring screw cap holder. So we can unscrew this cap. There is a small spring inside, okay, so which will hold the plates. Then the plates are to be placed here with the protector, and it is to be screwed again. So this can directly placed into the instrument. Now I will show you certain handling of the solids by forming the solutions. Take small quantity of the solid material in a small tube. Add Sufficient quantity of the solvent like your carbon tetrachloride or chloroform, depending upon the solubility of your samples. Use small droppers for adding the liquid. Shake to dissolve. Now I will show you the liquid sample cells. Again, it is kept into the desiccator. These are the desiccants. It is to be kept slowly into the cotton for prevention. There should not be any moisture. It is a fixed path length cell for holding of the liquid. A gasket is there which is maintaining the distance between the two KVR plates which are there, and a observation window is provided to see the level of liquid. Now we will place the liquid with the dropper from the lower end of the tube so that it will flow through the cell, removing any air bubble which is trapped between this. A care is to be taken that there should not be entrapment of any air bubble. The liquid is allowed to come out from the another end. So now the Teflon or plastic closures are used to close these tubes. Then it is to be hold into the compartment. It is having the groove to hold in the compartment. It is placed in this way, and the radiations are allowed to pass from this side to the sample and towards the detector. In this way, we can handle the liquid samples also. Now for the gases samplings, we are having a gases cell. Specially designed gas cells are there, which are having the inlet and outlet parts, and this cell is on the both end of this cell. The potassium bromide or sodium chloride windows are fixed so that the radiation can get transferred through these windows into this cell. So these are the specially designed gas cells. The very few organic compounds can be analyzed in the gaseous form. Example is your example of 1,4-dioxane that can be analyzed in the gaseous form. Mostly we can handle any phase of the material. We can handle the liquid, we can handle the solid, or we can handle the gases. So now the FTIR instruments, they are having the different sampling technique than this old one. Now the next component after the sample holder is the monochromators. So we have studied monochromators in details in UV visible spectrophotometers. So we can have the prism of the alkali halides are used as a dispersing devices. Again, I will explain you that we cannot use the glass or the quartz prisms because they are not transparent to the IR radiations. So these alkali halides are compressed to form the prisms. So these are very sensitive to the moisture. So whenever we are using such alkali halides prisms, the instrument should be kept into the desiccant always, and a desiccator lamp is always kept on to make it free from the moisture. So otherwise, if they absorb the moisture, a fogging effect will be appearing, resulting into the non-transparency to the IR radiations. So common material used for forming the alkali halide prisms are sodium chloride, potassium bromide, cesium iodide, etc. So lithium fluorides and calcium fluoride prisms provides improved resolutions. So these window cells are also formed by using the lithium fluorides and calcium fluorides for the purpose. So this is the first prism monochromators. We know that by rotating the position of this prism, we can get the different lights coming out from this exit slit. The another device which is commonly used are the grating monochromators, which are having the reflecting or transmitting gratings. So gratings are the grooved surfaces, polished grooved surfaces where the parallel grooves are prepared, the angular diffraction or the radiation take place, and rotation of these gratings will take out the different wavelengths and which can be used for the purpose of IR. So you remember how many grooves are there per mm. There is a difference in the number of grooves which are used for the UV visible and for the IR spectroscopy. So this is the second component, the monochromators. After the sample holder, let the sample absorb all the radiations, then that reaches to the monochromators. They are isolated and they are sent to the detectors. So detectors here, we are using the thermal detectors. Various thermal detectors which are used or we are going to learn includes the thermocouples, then bolometers, Golay cells, pyroelectric detectors, photoconducting detectors, These are used in case of the IR spectrophotometer. We will see one by one every detectors. First one is your thermocouples. So dielectric materials, these are the two metal plates. They are acting as a thermocouples. So thermocouple, it consists of a pair of junction formed when two ends of the metal, such as the bismuth and antimony, are fused either ends of the dissimilar metal wires. So heating capacity of the absorbing element is small as to the detecting change in the temperature. So the potential varies in the two junctions with the difference in the temperature. One junction is always exposed to the IR radiation and one junction is not allowed to expose to the IR radiation. That is known as the cold junction where the IR radiations are not bombarded. The another is called as a hot junction where the IR radiations are bombarded. So due to the unbalancing in the temperature between these two junctions resulting to the formations of current which will disbalance the Wheatstone bridge and the potential will flow through the circuit and that can be detected. So the current flowing through the circuit is equals to the amount of radiations which are falling onto this hot junctions. They are called as a thermocouples. The another one is your bolometers. So bolometer is a type of resistance thermometer constructed from strip of the metal such as platinum or nickel or from some semiconductors. This shows a relatively large change in the resistance as a function of temperature. It forms one of the arm of the Wheatstone bridge. A smaller strip is used as a balancing arm which is not exposed to the falling IR radiation. IR radiation falls on the bridge become unbalanced due to the change in the resistance occurred due to the change in temperature, like your thermocouples. This causes current to flow, which is measured of the intensity of IR radiation, which is falling onto this bolometers. The next one is your Golay cell. Golay cell, they are sensitive gas thermometers. So xenon gas is contained in a small cylindrical chamber which contains a blackened membrane on one side while the other side has a flexible diaphragm and which is coated with the silver outside. A beam of light is reflected from silvered surface to the cathode at a vacuum phototubes. So when the IR radiation falls on this blackened membrane, it hits, which is turned, hits the xenon gas, which is present in the cylinder, resulting into the expansion of this xenon gas, exerting the pressure onto the diaphragm, silver diaphragm. And how much pressure exerted is equal to the radiation which is falling onto the silver surfaces. So as a result, the fraction of reflection light which streaks the active surface of photodiode tube is changed, leading to the change in photocurrent. This is related to the falling IR radiation. So it is used as a Golay cell. The another one or the newer instrument they uses the pyroelectric detectors. Okay, so pyroelectric detector they are constructed from single crystalline vapors of pyroelectric material, which are dielectric material which has a special thermal and electrical properties. Example: deuterated thioglycine sulfate (DTGC). Okay, DTGC detectors. So they the modern instrument uses this um, glycol deuterated thioglycerin sulfates. Some salts are prepared and they are used. When an electrical field is applied across any dielectric material, electrical polarization takes place. The magnitude of polarization is a function of dielectric constant of that material, which can be measured as a function. So the pyroelectric crystal is a sandwich between the two electrodes, which are IR transparent. The IR radiation is allowed to fall on this material, resulting into the change in magnitude of current, which is directly proportional to the radiation which is falling, that can be detected. Then some instrument also uses the photoconducting detector. Photoconducting detector, they consist of a thin film of semiconductor materials such as lead sulfide, mercury, cadmium telluride, or indium antimonides deposited on non-conducting glass surface and sealed into the evacuated envelope to protect semiconductor from the atmosphere. So absorption of IR radiation by this material promotes non-conducting valence electron to a higher energy conducting state. This decreases the electrical resistance of semiconductors, and change in total current will be equal to the amount of radiation falling on this instrument. So another last component is your readout device or recorder, which will record as a graph. Now, the type of spectrophotometers we are having either conventional IR spectrophotometer, they are sold, they are not used. Now we are having only the Fourier transform instruments. So this dispersive, the conventional IR spectrophotometers are of the dispersive type. They are non-dispersive instruments like monochromators and prisms are used. They are frequency domain spectra they produces, and the intensity of the radiation reaching to the detector is very small, and they require more time as compared to your Fourier transform instruments. So they, instead of using dispersive devices, they are using the interferometers for different types of the radiations which are reaching to the samples. Okay, so interferometers function I will explain, but more detail is not with your syllabus. I will not discuss interferometers in details here, but I will just give you the basic principles. So there is interferometers are used. So they are having the time domain spectra. At a time, all the radiations are falling onto the material. Let the material want to absorb whatever radiations, and the remaining radiations they are separated and then they are analyzed. So they're requiring very small time. The all material can be scanned within a very small time period. Therefore, Fourier transforms are most commonly utilized. So they are having the high signal to noise ratio, the interference can be avoided. So these are the instruments. We are generally having the double beam instruments here. One beam of the radiation is continuously passing through the reference material, another is passing through the sample material. The difference between these two is measured. The effect of your sample or your reference is attenuated by the devices, and then they are sent to the monochromators where they will get separated and then sent to the detector. So they are the double beam instruments. So this is the Michelson interferometers. In Fourier transform instruments, these Michelson interferometers are used. They are working with the different principles of the preparing the interference in the path of the radiation. So what is the interference? There are two mirrors. One is called as a fixed mirror. Another one is called as a rotating mirrors. So when the waves passes, they are the mixture which is displaced at the two angles. A small distance of this mirror is moving continuously, so that the wave produced will propagate with a different angle, and that waves is bombarded with the sample. So they are having more intense radiations which are bombarded on sample. So the intensity of radiation reaching sample is more, so they are more sensitive, giving the good results. So therefore, all modern instruments uses the FTIR. Now, we have in previous lecture also we have discussed certain applications of IR spectroscopy. In brief, I will again discuss the IR applications. So you pause your video and you recall what applications you learned in the previous lecture. So pause the video, take the pen and notebook, write all the applications what you have learned. If you have finished, play the video again and see your answers and compare your answers with this. So application of IR spectroscopy, identification of functional group, generally for the structural isolation purpose, we are using it only to detect the functional group. And detection of impurities, it is very commonly utilized in monographs for finding the impurities. All monographs shows you the IR spectrum to detect the impurities. The test sample to be determined in compared with the standard samples. For the quantitative analysis, the quantity of the substance can be determined either in pure form or in a mixture of two or more compounds. So it can also be used for the quantitative analysis, but mostly for the qualitative analysis. So identification of substance in IR spectroscopy is used to establish whether a given sample of organic substance is identified by comparing with the another standard samples. It is also used for studying the progress of reaction. When any chemical reaction is processing, how much substance is formed, what is the reaction process, that can be studied by using your IR spectroscopy. Here we have completed all the topic of IR spectroscopy as per our syllabus. If you are more interested in the TIR, you see my another video which is available. Thank you and see you in the next unit. Thank you. Bye.